Okay, hello. We are going to continue in Module 1, and now that we know about rational numbers, we're going to talk about roots. What are roots? Well, before we talk about roots, we've got to talk about something else, and that is exponents. So, I think you probably know what exponents are, but let's just make sure. No, wait, you know what? Let's just take a break first. Let's do a little puzzle. Can you find the next numbers in this sequence? 2, 4, 8, 6. Oh, I see the pattern here. It's just doubling every time. And then it's multiplying by 2 again. And then it's multiplying by 2 again. Not too difficult. But what you might not see is that in this sequence you start with 2, and then you multiply that by 2, and then you multiply that by 2, so that you've got 2 times 2 times 2, and then you multiply that by 2, and you multiply that by 2, and if you kept on going, you would eventually just have tons and tons of 2's. And that's all great, and that's a nice and lovely pattern there. But what I want to point out here is, if you had 2 times 2 times 2 times 2 times 2 times 2 times 2, there's got to be an easier way to say that and write that. And there is. And we do it with exponents. Exponents take a big, long expression where you're multiplying the same thing times itself over and over and over again, and abbreviates it, shortens it into something shorter and sweeter, like 7 to the 6th power instead of 7 times 7 times 7 times 7 times 7 times 7. You can also call this 7 to the power of 6. I think this is probably review, but just in case you don't remember, the 6 is the exponent with the 7, which means you're going to multiply 7 times itself 6 times. All right, it means repeated multiplication. Now, that means that 3 to the 4th power would be what? It would be 3 times 3 times 3 times 3. And if you multiply that out, you get 81. If you do 10 to the 3rd power, that'd be 10 times 10 times 10. Which, if you multiply that out, comes out to 1,000. And if you add 23 to the 1st power, I guess that's just 23, right? Yeah, okay. So, what's 10 times 10? Well, that's an easy one. That's 10 to the 2nd power, or 10 to the power of 2. Or, we could also call this one 10 squared. When it's the 2nd power, we call it 10 squared. It's a nickname. And when it's the 3rd power, or to the power of 3, we call it cubed. These are special nicknames for an exponent of 2, which is called squaring something, and an exponent of 3, which is called cubing something. Okay, you probably already knew that too, because you're so smart. But can you use an exponent to rewrite this? Try it in your journal. And then once you're done with that, try this one. Take 5 to the 4th power and tell me what it comes out to. And now that you know all about exponents, we can do this little exercise. 1 squared, what is that? Well, that's just 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. What's 7 squared? 7 times 7. Oh, that's 49. And maybe you don't know what 12 times 12 is, but it's 144. These are easy when you square a number. The thing about this last one, though, is we're not squaring 100. We're not going to do 100 times 100. We're trying to figure out what times itself makes 100. And in order to figure out what that number is that should go in the blank spot, you kind of have to unsquare the 100, don't you? You have to try to go backwards in your mind. What times itself? Well, I know 5 times 20. No, that's not. 2 times 50. No. 4 times 20. Oh, 10 times 10. That's not too difficult. But what you just basically did is unsquared the 100 because you needed a number times itself that made 100. And when you unsquare a number like that, you just found what's called a square root. Okay, so a square root is when you unsquare something, and 10 is the square root of 100. The way we write this in math with the square root is with this kind of a funky little symbol that looks like this. 10 is the square root, with that crazy symbol, of 100. And so if I said, what are we trying to find here? We're trying to find the square root of 25. So what times itself makes 25? Oh yeah, 5 is the square root of 25. Okay, easy enough. By the way, that crazy symbol, it's called a radical. And a radical just means that you're supposed to square root the number inside of the radical. So, could you square root 64? It should be 8, right? Could you square root 4? Should be 2, right? What about 81? Oh yeah, that's 9 times 9. Square roots aren't that hard. The square root of 49 is 7 because 7 times 7 makes 49, and you unsquare the 49 into a 7. But what if you have 3 to the third power, 3 cubed? We know that's 3 times 3 times 3, which comes out to 27 when you multiply it. But if we wanted to go backwards from the 27 to the 3 that got cubed, if we wanted to uncube that 27, what would we do? Would we use a square root? No, we couldn't use a square root because that would be unsquaring it, and we want to uncube. So if you want to uncube something, you have to do a cube root. A cube root is just like a square root, but instead of unsquaring it, you have to uncube it. So we're not saying what times itself makes 27. We're saying what times itself makes 27. And since 27 is 3 times 3 times 3, the cube root of 27 is 3. We uncubed it. So what about the cube root of 125? Oh yeah, that's a tough one, right? What times itself makes 125? Cube roots aren't always as easy as square roots, so sometimes it helps to make a factor tree. What I mean by a factor tree is, can we break 125 down? Is it 5 times 25? Check it on your calculator. It is. And then can we break the 25 down? Oh yeah, 25 is 5 times 5. Wait a second. 125 is 5 times 5 times 5. Therefore, the cube root of 125 is 5. And you can check it by doing 5 times 5 times 5 and seeing if it gives you 125, which it does. So that's a cube root. All right, what about the cube root of 1,000? We'll do this one quicker. 1,000 is 10 times 100, and 100 is 10 times 10. So isn't 1,000 10 times 10 times 10? Sure it is. Therefore, the cube root of 1,000 is 10, because 1,000 is 10 times 10 times 10. Now it's your turn. Can you do this? The square root of 9. And can you do this? The cube root of 8. Try them and see what you come up with. And once you're done with that, we need to talk about something else. We just did the cube root of 8. Hopefully you got it right. We'll see tomorrow. But you can also do fourth roots, and you can also do fifth roots. Now, the number 8 doesn't really have a fourth root or a fifth root because nothing times itself times itself times itself makes 8. But it is possible to do any kind of a root. You can unfifth something or unfourth something. Okay, that number above the radical is called an index. And if you want to pause this video and read this little paragraph, you can. But what it basically says is you can do square roots or cube roots or fourth roots or fifth roots, and that index tells you which kind of a root you're doing. And if you're just doing a square root of a number, you don't have to write the little 2, because if there's no number there, we just assume it's a square root. Okay, one more thing. What if I asked you to solve this equation and tell me what x equals? You would probably know pretty quickly that 16 is 4 times 4, and therefore x must equal 4, right? Well, kind of. You're almost there, because there's something else tricky about this. Couldn't you make 16 by doing -4 times -4? Wouldn't -4 squared give you 16? So therefore, does x just equal 4? No, x could equal +4 or -4, and we use that little plus-minus symbol to mean that x could be 4 or -4. Tricky, huh? But it's true. All right, so try to tell me, what does x equal if x squared is 100? And I'll give you a hint. You should use that little plus or minus symbol. Okay, that's it. Thanks for watching. Thanks for listening. Hopefully you took good notes. And if you have any questions, write those things down in your notes, and we will talk about it tomorrow.